6, 2, 2, 6. For number 1, for section 1, for section 1, does y bar fall in the center? No. So are we looking at the axis going through the center or an axis not going through the center? Axis not going through the center. If the axis was going through the center, which equation would I use? BH cubed over 12, because that's the one going through the center for a rectangle. But it's not going through the center. So what do I have to do? I have to use the parallel axis theorem. So y bar is going to be equal to y bar through the center plus x bar squared times the area. At least for this one, right? Maybe we should not, right? Maybe we should just write the equation here. And here's my y-axis, right? Right here. Through the center. And here's my y bar through the center. Y through the center. So, what is the moment of inertia equation for the axis going through the center of a rectangle? B h cubed over 12 plus, what does this bar here represent? What does this bar represent? The perpendicular distance between the two axes. This is the one going through the center, and this is where the y prime is. What's the distance between this? 1 squared times, what's the area? We know is 12. If y bar is in this direction, what is my base? 6. 6 times 2 squared over 12 plus 12. And what's that come out to be? 4?
2 cubed. 2 cubed.
Oh, yeah. 8.
Oh, cubed, right. So that's 8. 8 times 6, 48. 4, 16. And what units is it?
That's the parallel axis.
Inches to the 4. Do that. Let's make sure we get it. So, for section 1, it's a composite body. This thing's made up of 2 parts. Everybody look over here. For part number 1, for section 1, they want us to find the moment of inertia about this axis. Will the moment of inertia about the y prime axis be greater than the moment of inertia about the y-axis? Yes, because there's more material here. Does the y prime go through the center? No. So we are not following this rule, because this rule, you look at the table. Look, use. Use equation on table. Instead, y prime is not going through the center. That's this case. We have to use the parallel axis theorem. So the parallel axis theorem says, I really don't like this. I really want this to be x sub c. Would you be confused if I changed it?
No.
I would really like to go back here. Can we do this, you guys? Make all this C, 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 because this really,
Corinne, I can't see.
oh, thank you. Wait, you get out there. So I'm making all the axes that are going through the center sub C. So that means this is going through the center, and then we can leave the prime if we want.
I don't like that the height is too height along that.
So if you look in my notes, the B always stands for the side, the distance of the side parallel to the axis. And H stands for the distance of the side perpendicular to the axis in question.
Okay, so since 2 is.
So since we're talking about the y-axis, the side parallel is 6, so 6 is B, and 2 is H. Chelsea?
I guess it, I don't know, just, the answer, when I did this one, I couldn't get the answer in the back of the book, but I did exactly what you did, so.
Did you get the answer on my, my solutions only had 33 in it, didn't it?
130 something, and I forget that.
No, number, did I do number 31? I thought it looked like my solution started with 33. All right, well, let's keep going. How are we doing? Okay, so in this case, we're trying to find, here's the y sub c, right? For the second section. Well, where do they want to find the moment about? They want to find the moment about this, y bar, right? So if they want to find the moment of inertia about y bar, does y bar go through the center of this object? No, so can we use this equation? No, this is only if it goes through the center, right? What we have to do is use the parallel axis theorem, and then we do use this equation, but we have to add on to it. So, here, I sub y prime is equal to y sub c plus x bar squared times the area. So again, what's the equation? bh cubed over 12 plus, what is the perpendicular distance between these two?
3.
Is it 3? Yes, 3. So it's 3 squared times the area, which is 12. And in this case, if we're looking at y this way, what is the base? What's the base, you guys? Try again. The base represents the distance of the side that's parallel to the axis. If we're talking about the y-axis, what's the base? 2. Hang on a second. So it's 2 times 6 cubed over 12 plus 9, 108. So what does that turn out to be? What's 6 cubed? 36 times 6 is? Could somebody do the math here?
198.
The answer is 36?
No, that's the first.
198.
198?
I'm getting 144.
144. Okay, Sam.
So the X bar you have as 5 in your table, but then you use 3 in your
Good question, that's really great. It's confusing. Because this y, this x bar represents the centroid. These are the centroids. And then the damn equation uses the same variable. But the variables here represent the perpendicular distance between the axes.
What's up with that, Joanne?
Yeah, I don't know.
These are between the center of the.
Well, it's
centroid
between
and
these
X,
two
B.
axes, which is the distance.
X is your imaginary
Right,
axis.
that's right.
Okay.
Because these equations are based on
That's why I kept getting it wrong.
the
because
X.
I was putting
The wrong X.
the wrong X.
So Sam, I'm really glad you mentioned that. So we're using all these equations, but all these equations only work with the axis going through the centroid. Then we have to add that extra piece to it. And that extra piece has to do with the distance. Doesn't it make sense it's gotta be the distance from the center axis? Squared. It's a weird thing, it's a weird calculation. I mean, I think it's pretty cool that somebody figured this all out. And then this stuff connects to designing beams and bike wheels and columns. I think it's all cool that they figured that out. I don't know who did it. Maybe it's Mr. Inertia or Miss Inertia, I have no idea. But anyway, it's cool, but it's you have to be meticulous, right? Sam?
So once we get the moment of inertia around the y
Yeah,
prime.
good.
the-
So then what's the next step? So we found that the moment of inertia about this piece is 16. We found the moment of inertia about that axis of this piece as 144. First question, does it make sense that the moment of inertia about y prime of this body 2 is greater than body 1?
Yeah.
Why?
There's more mass.
There's more area, there's more material further away, right? So the higher moment of inertia. But what was the question? The question asked us what the total moment of inertia was. So we add these two. 124. And what's the units? Inches to the 4.
That's not.
No, sorry. 16. Thank you.
160.
You already carried the one.
One,
Right, no, this is wrong. Sorry. I don't know what I'm doing. So 0, carry the 1, 160. Chelsea.
So this is when I did this problem, I couldn't figure out what I was doing wrong, because you had the distance as 2 for both of those,
yeah.
and
In the
I don't know where you
solutions?
got that,
Yeah.
yeah.
And you have the same answer as the back of the book, and the back of the book has 136, and that's what your answer online is.
Here, you want,
But I
Okay,
just
I
did
know this is right.
162.
Well, we just did it, we did it all together, so we checked each other. So does that mean I made a mistake in one of the
And
solutions?
so did the book.
but the book
like,
has the same
must have
answer you did.
Oh,
So I
really?
didn't understand what I was doing wrong.
It's just a different answer than what has a solution.
Yeah.
Okay, well, the only solutions I have starts with number 33, so
Online.
I'd like to check. Yeah, so I only printed out what I had. Yeah, okay, so what number is 31?
31.
Okay. I'll check.
Joanne,
Yeah,
why is the centroid of section 2 the x5? Wouldn't it just be 3 if you were doing that section?
Oh yeah.
Why did you add 2?
Yeah.
You're just doing
oh,
section.
because look, because we are measuring the centroid of X bar all the way from the left. So everything you do is based on the axes that you're choosing. And we chose this as our y-axis, and we said we were measuring the centroid from here. So the centroid of this would have to be 2 plus 3.
But the moment of inertia is relative to the y prime.
So the X bar is measured from the y-axis, and this is measured from the x-axis. So here's my y-axis going up here, right? And here's my x-axis. And I measured my centroid from the y-axis. So the x bar for this piece right here, it cuts off, right? It's 2 plus half of 6.
Okay, because it would be the centroid, but then it's over 2.
Right, because the centroid would be here, right, where this is 3 and this is 3. But you gotta add that 2 in, because you're measuring it from there. So pictures are really good, you know, showing where all the axes are. Sam?
So since our y prime is in between the two,
Bodies.
yeah, two bodies, they're on different sides of the axis, would they not subtract from each other?
Oh.
But we're spinning around the axis, so we're just.
That's a great question, that really sounds like a bonus point question. Yeah.
It's the same.
So you're asking us how much we would take to spin around this y prime axis? Right, so it wouldn't.
I think not, I think it still gets added, because, what, Lonnie explained it again?
So I think what we're asking is how much would it take to spin around this y prime axis that was chosen?
Right.
So it doesn't matter what side or, even in 3 dimensions, we're spinning around that axis, it's how far away it is from the axis.
Yeah.
So it takes the same amount to spin it, no matter where it is.
So let's see, but would it have a different moment of inertia? But what if this body was here instead? That would mean that it would have the same moment of inertia.
Except you have double.
Okay, so let's think of spinning something, right? You have a ball on both sides.
Is it easier to spin than one ball? No, it's twice as hard.
Right.
When you really start to spin something, you just have one mass. So you just have twice as much. Definitely they don't count around as much.
So if you have a pole, and you have a wire coming out in a circle, like a wire, and you had a ball here on one side, and you had a ball here on the other side. So they were on 2 different sides, but eventually the 2 balls could slide to be next to each other, and they're still creating the same. I think it's okay. But let's ask them. Are you going into physics now?
No.
Okay. Well, physics. Let's ask the physics folks. Yeah.
I would say if you have one ball in the circle, it's going to be, this amount apart to get started. But if you have 2 balls, it's certainly not going to make it back to the same as 0 balls. If you have 2 or 4 or 3,
Right.
they don't keep canceling each other out. They just get harder and harder and harder to spin as they.
And hard to spin is the moment of inertia.
Yeah.
Maria?
Would we look at the whole picture together, because the white bar, when we found the center, it is at the white bar.
Well, what's happening is you're spinning about this bar, and this material out here is causing it to rotate, and this material is causing it to rotate. And this material is a greater distance, so it's going to cause it to rotate, but I think it's a sum. But so is this the correct answer? Oh, so we think the book has a different answer. So let me look into it more, okay, to see, but I don't think you would subtract them. The only time you would subtract them is if you look at a different problem. All right, we look at this problem 34, where how many bodies would you divide this up into?
You could do 2 and subtract 2, or you could do.
Let's do the least amount.
4.
Okay, here 4. Can anybody get down to 3?
3.
What's 3? 1 positive and 2 negative. We have a rectangle, and then we have a circle and a triangle. In this case, the moment of inertia of the circle and the moment of inertia of the triangle would be separated, would be negative, because there are not negative masses or areas.
Okay.
Okay, so that's one where it would be subtracted. So let me look at this problem then and make sure that it's correct.
And then I was also thinking too, for the X bar for the first one, how come you don't compensate the other piece? So like the 1 plus 30.
1 plus 30.
3.
Mean this one?
Yeah.
Okay, so this one is the centroid. So we're looking at what is the centroid of this body, right? And we're measuring everything from y bar, so it's 1 over,
Yeah.
right? So that's what this one is.
Okay. Yeah, I got it.
Okay, could you take a photo of this and then text it to me? So how how did this work out? So that means that there have been 3 times that I flipped the classroom, right? The first one was distributed loads, right? I flipped the classroom, watched the video. You came in and you were with Karen. And I don't think she did a summary, but then I did a summary when I came back, and that's when you said that you like this, you know, like a 15, 20-minute summary after the videos. So the next time we flipped the classroom was for centroids, and I asked her to do a brief summary. So did that feel good? Okay, and then today, we did what you wanted. You saw the videos, we did a summary, and then we started. It'd be nice to have more time to do more problems, though. Before you, I want to hear the suggestion about the process rather than the question on